All right, welcome back to The Explainer. I'm stepping into the lab today as your senior MQL5 engineer to tackle something I am personally super excited about. For years, quants and developers like us have hit this really frustrating bottleneck. How do we take the absolute cutting-edge data science capabilities of Python and link them directly to the unmatched execution muscle of MetaTrader 5? Well, today, we are going to build that exact bridge.
So here's our roadmap for today's session. We'll start with the Python MT5 bridge, map out the connection lifecycle, and hit high-performance data retrieval. From there, we'll dive into structuring trade requests, look at direct trade execution, and then finally pull the whole shebang together into the automation big picture. Let's get to it.
Section 1. The Python MT5 Bridge.
Now, a lot of people think bridging these two requires some hacky workaround. Actually, scratch that. It is absolutely not a workaround. We're talking about a native API built directly into MT5 that gives your Python scripts low-latency access to terminal data and the execution engine. Think of it like this. Python is your analytical brain, right? It's where you run your machine learning models, slice and dice those massive Pandas data frames, and run complex statistical forecasts. MetaTrader 5, on the other hand, well, that's your trading muscle. It handles the broker connection, manages your order queues, and guarantees that rapid execution. Bridging them? That gives you the ultimate institutional-grade setup. Moving right along to Section 2, the connection lifecycle.
Getting this connection established is basically a three-step chronological journey: initialize, login, and shutdown. Visualize this as a secure data handshake. First, you open up the communication port. Next, you verify your identity with the broker. And finally, and this is key, when your algorithms finish their job, you securely terminate that connection. Because, as we all know, nobody likes a memory leak.
Looking at the Python code, that handshake is incredibly straightforward. You explicitly call mt5.initialize to start the terminal process, and then you follow that right up with mt5.login using your credentials. And look, absolutely zero market data is going to flow until those two steps succeed. Once you're done, just like any pro engineer cleaning up their workspace, calling mt5.shutdown is mandatory to end your session safely.
All right, Section 3, high-performance data retrieval. So, once the bridge is up, we need data to feed our models. Now, what's really interesting here is the clear distinction between our two main retrieval functions. On the left, you've got copy_rates. This pulls your standard OHLCV bars for specific timeframes, say your 15-minute or 1-hour charts. But on the right, you have copy_ticks, which grabs high-speed raw tick data. We're talking immediate bid, ask, and last traded prices. Basically, you're going to use copy_rates for macro structural analysis, but you'll instantly switch over to copy_ticks when your strategy needs that microsecond precision, like if you're scalping or running high-frequency stat arb.
When you do use copy_rates, the data comes back in a very strict C++ style format called the MQL rates structure. It neatly packages everything: time, open, high, low, close, volumes, and spread. But here's the true beauty of this native integration. This format is practically begging to be used in Python. With literally one line of code, you can convert this raw array directly into a Pandas data frame. Bam! You instantly unlock Python's entire ecosystem of vectorized math and backtesting libraries. It's a total game changer.
Section 4. Structuring trade requests.
I know the official MQL trade request documentation can look pretty dense and intimidating at first glance. So let's just demystify it right now by chunking it into this cheat sheet of mandatory fields. If you want to send a standard market order, you have to set the action field to trade action deal. Obviously, you need to specify your symbol, like EURUSD, and your volume in standard lots. Then you explicitly define the order type buy or order type sell, and pass the requested execution price. Honestly, that's it. These specific fields make up the absolute minimum payload your Python script has to assemble to command the MT5 engine.
But that brings us to a huge, absolutely critical question for anyone making the leap to live markets. How do we safely execute and verify this trade request in Python? Because let's be real, risking live capital takes a lot more than just firing off a data packet and crossing your fingers. We need strict validation.
Which leads us perfectly into Section 5, direct trade execution.
The golden rule here: we never, ever blindly send an order to the broker, period. We use a rigorous two-step execution sequence. Step 1 is MT5 order check. Think of this as your built-in safety net. It simulates the trade internally within the terminal, validating your margin, checking the price, making sure the volume is allowed, all before a single byte of data goes to your broker. Only if that internal check passes do we proceed to step 2, MT5 order send, which fires the actual live request into the market. Translating this into Python is super elegant. You literally just wrap your execution logic in an if statement, checking the Boolean return of mt5.order_check. If it's true, you run mt5.order_send and capture the result. But listen, the discipline doesn't stop there. You have to interrogate that MQL trade result object for a specific return code, 10,009, also known as trade_retcode_done. Seeing that code is your absolute 100% confirmation from the broker that your live trade just executed successfully.
Section 6. The automation big picture.
Now, take a look at the fractal dollar signs mapped right onto this daily price chart. This, right here, this is the ultimate end goal of our integration. Just imagine your Python script running continuously on a server somewhere, pulling down tick data, crunching complex models in the background, and generating precise algorithmic signals. Those signals instantly translate into perfectly timed, automated trade executions, just like you see on the screen, without a single manual intervention. It is a flawless, closed-loop system.
So, we've walked through the connection lifecycle, we've looked at high-speed data retrieval, and we've nailed down the nuances of direct, verified trade execution. With Python acting as your analytical brain and MetaTrader 5 serving as your execution muscle, the possibilities for your algorithmic trading are, frankly, limitless. So I'll leave you with this final thought. Armed with this powerful API bridge, what strategy are you going to automate next? Dive into the docs, start writing your integration scripts today, and I'll catch you next time on The Explainer.